All right, welcome back. So today we are going to be talking about how to analyze the graphs and tables of proportional relationships. Last time we started talking about what does it mean to be a proportional relationship, and today we are going to be analyzing the graphs and tables of proportional relationships. So without further ado, let's begin. So we have a big phrase to talk about. The big phrase is called direct variation. So direct variation is our key idea today. What direct variation means in words is when two quantities, x and y, are proportional, the relationship can be represented by the direct variation equation y is equal to mx, where m is the constant of proportionality. We also refer to the m, if you recall, as slope. And when we're talking about graphing, the graph of y equals mx is a line, keyword, it's a line with a slope of m that passes through the origin. So again, notice the graph goes through the origin, which is 0, 0. So if we're looking on a coordinate plane, we look at the origin. The origin is right here, 0, 0, is where that x and y axis intersect. So when we talk about direct variation, there's two main components. One is that it goes through the origin. That is the first main component. It has to go through the origin if we're looking at the graph. If it goes through the origin and it's linear, that's awesome. The second main component is that we can write an equation again, which is y is equal to mx. If we're able to write an equation y is equal to mx, then we're also going to be able to graph this linear equation. And we'll get to that a little bit later, but I want you just to be aware that any line that we see, we can write an equation for that line. And specifically, when it comes to direct variation, it has a special equation, y is equal to mx. When we have a proportional relationship, again, like 2 apples to 3 oranges, well, we could write that as an equation. We could write y is equal to 2 over 3x, right? If you earn $10 an hour and you wanted to graph how much money you earn over time, well, you could have it as y is equal to 10x. It's $10 per hour. That's a proportional relationship. In 1 hour, you earn $10. In 2 hours, you earn $20. In 10 hours, you earn $100. $100 bills, y'all. So when we can eventually graph these proportional relationships by using the equation y is equal to mx. When we're analyzing a graph, as we're going to be doing today, analyzing graphs and tables, we have to see, does that line go through the origin, right? And it has to be a line. And we eventually will be able to write these equations as y is equal to mx. So let's talk about some examples here. On this screen, there are 4 different situations. We need to tell whether x and y are proportional x and y are in a proportional relationship. And we want to explain how we know. So we want to see, okay, do these graphs show a proportional relationship? Do they go through the origin? Are they straight lines? So I'm going to give you a minute. Please identify the proportional relationships and the non-proportional relationships and be ready to explain why they are or why they are not proportional. All right, so hopefully you attempted A, B, C, and D. Let's talk about A. We're talking about money, right? The main idea is money. And we have our y-axis that represents earnings in dollars, and the x-axis is hours worked, okay? Does this go through the origin? Yes, it does. So A is a proportional relationship. And if we try to analyze it, let's look at it. Let's look at the coordinate points at it. Well, I see that at the first coordinate point, my x is 1, that's hour. So in 1 hour, I earn $10. Then in 2 hours, I earn $20. 3 hours, I earn $30. So we have this constant rate. We try to find the slope. We figure out it's 10. It's $10 per hour. So this would be $10 per hour. If we were to explain it in words, it goes through the origin and it represents $10 per hour. Awesome. Let's go over to part B. We're talking about helicopters. We're talking about height in meters as our y-axis and time in seconds as our x-axis. Does this represent a proportional relationship? No, it does not. It does not, because it does not go through the origin. It would have to go through the origin, and it doesn't. Remember, the origin is 0, 0. It doesn't go through the origin, so it's not a proportional relationship. Let me move this out of the way. Let me move this out of the way. If we down, sorry, if we look down at letter C, we're talking about tickets. And we're talking about the cost of tickets as the y-axis and the number of tickets as the x-axis. So we need to ask ourselves, does this represent a proportional relationship? Does it have a straight line? Does it go through the origin 0, 0? No, it does not. And if we look at it, we would want this to go through the origin. We would want to have a relationship with 0, 0. Because 0, 0 in this specific setup would be, if I buy 0 tickets, I pay $0. That's what the interpretation would be at that coordinate point, 0, 0. 0 tickets is $0. But right now, it's not going through the origin. It doesn't show that when you buy 0 tickets, you pay $0. Right now, it looks like if you buy 0 tickets, you're paying $10. Whoa, that's not fair. I don't want to pay for something that I'm never going to get, right? That is a very bad situation. So this is not proportional. It does not go through 0, 0. We shouldn't have to pay for tickets that we never actually acquire, right? And now let's look at part D. We're talking about pizzas. Pizza, pizza, pizza. We're looking at the y-axis is the cost in dollars, and the x-axis is the number of pizzas. Well, we want to look at it and say, okay, is it a line? Yes. Does it go through the origin? Yes, it does. So part D is proportional. And if we wanted to talk about and analyze this graph and come up with a relationship between it, let's look at the coordinate points. Well, we have this coordinate point right here. We have that coordinate point right there. This coordinate point right here. This one right here. And that one right there. So they kind of don't look perfect when it comes to intersecting. But the main one that I want to look at is actually going to be $30 for 5 pizzas. Let me get out my eraser. Yes. Bye. Because I want to look at a perfect relationship here. And I think a perfect relationship is right here. So remember, this is 5, 30. And if we're talking about the direct relationship, the real world relationship between 5, 30, right? Like, what does that mean? If we look at the graph, we have our y-axis is the cost and the x-axis is the number of pizzas. So that means we paid $30 for 5 pizzas. So we paid $30 for 5 pizzas. Well, how much would one pizza be? What would the direct relationship be between the number of pizzas and the money that we are spending? How much would one pizza be? Yeah, it would be $6. That should have been green. $6 per pizza. So we really paid $6 per pizza. And we were able to figure that out because we saw there was a perfect intersection of the grid and the line at $30 for 5 pizzas, at 5 comma 30, which is 5 pizzas for $30. Well, if we wanted to figure out how much one pizza is, well, we divided 5 and 30 by 5, and we got one pizza was $6. And when we speak it, we normally say, "Oh, it's $6 for per pizza." So that's how we're starting to analyze these graphs. Does it go through the origin? Is it linear? Is it a straight line? And if so, what is the relationship that we are able to form here? Awesome. Great job. Let's talk about a table. Let's talk about two tables, actually. So our job here is to tell whether x and y are proportional and if they're in a proportional relationship. We have to be able to explain. Essentially, what we want to do here is we want to see if we can multiply each x to get y by the same number in each relationship. Here is what I mean by that. If I take my x value and I multiply it by a number, I should get the y value. And that same number should appear every single time. So if we have an x value of 1, we have the y value of 90. Well, I multiplied by 90. That means one lap took 90 seconds. So that means I should be able to multiply 90 each time in every relationship. That means I should be able to do 2 times 90 to get my y value. But look, the y value for the second lap was 200 seconds. I have to multiply 2 by 100 to get 200. That doesn't show a proportional relationship because we're multiplying by a different factor from our x to our y. So since we can't do that, we can't find that constant number I'm multiplying my x times the number to get my y, the red table is not proportional. This is not proportional. Sad face, because we want to have some kind of proportional relationship. But let's look over at the yellow table. I know there's fractions, that's okay. Remember, we want to take our x value, multiply it by a number to get our y value. Well, let's look at the first x value. The first x value I have is 1/2, and I end up with 1. What do I have to multiply 1/2 by to get 1? Yeah, I have to multiply by 2. Okay, so because 1/2 times 2 gives us 1. If I have 2 halves, I have a whole. So in order for this whole table to show a proportional relationship, I should be able to multiply each x by 2 and get that corresponding y. So let's go on to the next x value. The next x value is 1. The y value is 2. Look at that. I multiply 1 by 2 and I get 2. Now we have 1/2 and we end up with 3. 1/2 times 2 gives us 3. And the last x value we have is 2. We end up with 4. 2 times 2 gives us 4. So yes, since we are able to find the number that we multiply throughout that's the same, this will be proportional. So let's write that. Yes, this is proportional. Because each x value is multiplied that did not turn out to be multiplied. Hold on, let's erase that and try it again. By a factor of 2. So we would say yes, this is a proportional relationship because each x value is multiplied by a factor of 2. So every single time we took the x value, we were able to multiply it by 2 to get that y value. In the red table, we were not able to find the same number that we multiply the x's by to get our y's. We looked at the first relationship of the x and y was 1 to 90, so we multiplied by 90. Then we looked at the second x, which was 2, and the second y, which was 200. We would have to multiply 2 by 100 to get to 200. And 90 and 100 are not the same number. They're not the same factor. So that's why the red table was not proportional, but the yellow table is. Awesome job with this, folks. Keep up the great work. If you have any questions, please do not hesitate to reach out.